we've already been using the y-intercept in slope-intercept form, but we also know about the x-intercept. It's where it crosses the x-axis. The y-intercept is where it crosses the y-axis, just like they sound, right? And so if I have an equation and I want to use algebra to find the x-intercept, this is like when we found the zeros. We set the y equal to 0. So if we replace y with 0, and if I could say set it equal or replace y with 0, if I want to find the y-intercept, then I set the x equal to 0. So, for instance, I'm going to show you one that's more likely this would be helpful. If it is in standard form, and that was my equation, if I want to know the x-intercept, then I'm going to replace the y with a 0. And then really what happens here, if the y is 0, this entire part is 0. 2 times 0 is 0. 3x plus 0 is just simply 3x. So when in standard form, when I let the y be 0, the whole equation just becomes 3x equals 12. I can divide, and x is 4. So I know that there would be a dot on my graph on the x-axis at 4. And then if I wanted to know the y-intercept, then I would let the x be 0. Well, if the x is 0, 3 times 0 is 0, so the 3x is gone, and I just have 2y equals 12. And I can do that division in my head and get 6. And then I would know that this equation crosses my x-axis at 1, 2, 3, 4, and my y-axis at 1, 2, 3, 4, 5, 6, and I could just simply connect those two dots. So I could just find those 2 points with 2 quick divisions. Now, if those divisions did not give me whole numbers, then I would need to change it into slope-intercept form. Okay, so if the division would not give me a whole number, then I would need to change it into slope-intercept form. But I find the idea of the intercepts to be most useful when it starts out in standard form, which is not the example that we're going to have here first. It says, find the x and y intercept of y is equal to 3x plus 6. We can still use the same idea. The y-intercept is easy, right? We already know it should be 6. So if I said y equals 3 times 0 plus 6, well, that is, of course, 0 plus 6. So yes, the y-intercept is 6. We kind of already knew that because it's in slope-intercept form. If I want the x-intercept, it's a little more work. So that means the y would equal 0. So this is for the x-intercept over here. The y would equal 0. And then I solve the equation for x. So after you let the y equals 0, you have to solve the equation. So in this case, that would mean moving the 6 over and then dividing by 3. So the x would be -2. So it's not it's not just a division like it is if it was in standard form. But if I'm finding the x-intercept, you let the y be 0, and then get the x by itself. If I want the y-intercept, I let the x be 0. Now, if it's in slope-intercept form, I shouldn't have to do anything to find the y-intercept. I could just immediately write 5 and -8 here, right? Because if the y is by itself, that number out there at the end is the y-intercept. If you put 0 in for x, you still get the same thing, but we're doing too much. I didn't really need to do this. That's kind of taking the long way and giving myself a chance to kind of screw things up somehow. The x-intercept for these problems is going to be a little more work. I replace the y with 0. Remember, this is like find x-intercepts are the same as your zeros or your roots. So it's like what we did at the beginning of this packet. And then I need to get the x by itself. In this case, I could move the x to the left or move the 5 over, either one. I'm going to move the x over for a change, because then he's going to be positive. And then I don't have to worry about dividing. You could have moved the 5 and then divide it by -1. So the x and y intercept can be at the same number. That's possible. For number 2, we already said the y-intercept is -8. Again, if I did put a 0 in for x, a half of times 0 is 0. 0 minus 8 is -8. But if I want the x-intercept, the 0 goes in for the y. And remember that that happens because any place on the x-axis, the y would be 0 because it doesn't go up and down. So here I'd want to move my 8 over. I mean, you could move your x over if you want. And then to get rid of 1/2, we would multiply by 2. So I get 16 for my x-intercept. Now, if we had to make the graph, that might be a little big because it would not be on most of our graphs, but there's nothing wrong with having an answer that big as your x-intercept. One half wasn't too bad to get rid of because the top of the fraction was 1. We have a little bit more trouble or more work, or not necessarily trouble, but a little more work to do for number 3. Number 3 there, again, the y-intercept, if the y is by itself, the y-intercept is just that constant, so that's 2. And my x-intercept, let the y equal 0. Move either the x or the constant over. You don't want to start dividing until they're on opposite sides. And then to get rid of that fraction, we can use the reciprocal, which means flip the fraction over. And in this case, the x-intercept is not a whole number, which is not uncommon. You could also just multiply by 3 and then divide by -4. If the reciprocal kind of wigs you out, you can just multiply by the bottom of the fraction and then divide on a separate step. I get 6 over 4, which would reduce to 3 over 2, or 1.5. Since the decimal comes out neatly, you could also give it in a decimal form. Do not give me a decimal if it's like messy and you're like, how many places should I round? Then don't. And then the next ones are the ones where this is where I love using my intercepts, and I would prefer to graph. It's faster that way than moving it into slope-intercept form. And this is where if we, this thing is just being so contrary today. So neither of them are just look at it and there it is, okay? You need to remember when it's the x-intercept, just focus on the x. So it's basically like you're going to do these two equations. Now this one is like that's it. There's no division. And the other is this. So here you're going to solve this equation and you're going to solve this equation. Because when I replace the other variable with 0, that entire term becomes 0. So for the x-intercept, it is just 2. I mean, you could write as an ordered pair 2, 0, but just 2 is fine. For the y-intercept, we need to divide by -1. So the y-intercept is -2. Now, if you wrote that as an ordered pair, it would not be -2, 0. It would be 0, -2. Because any place on the y-axis, the 0 would be in the x position. Just like that's why we replace it with a 0. So quick division, 12 divided by 3 is 4. 12 divided by -2, -6. And then I can just find those 2 points to make my graph. Now, if you have something like number 6, here, if I divide both sides by 8, this is not pretty. I would not want to make a graph and have to estimate where -5/4 or -1.25 is. These boxes are really small. Trying to be accurate and put it at 1.25 would be difficult. So if I had to graph this, then I would probably choose to go ahead and put it in slope-intercept form. But if all I'm being asked is for the x and y intercepts, then I can, those fractions, even if the fraction was 5/7 or something that doesn't have a decimal equivalent, it wouldn't matter. So the next part is our graphing from the intercepts. And you can write down as much as you need to write down, but most of you are going to find after a little practice, you don't need to write much down if you're using the intercepts. So if I want the x-intercept, the y becomes 0, so I'm just left with this. Oh, x is 3. So then I'm going to put a dot on the x-axis at 3. If I want the y-intercept, the x is 0. So if the x is 0, it's just y equals 3. So y is 3. That's on the y-axis, 1, 2, 3. Because we're talking about the intercepts. I'm not talking about the whole vertical and horizontal line. I'm just talking about the intercepts. And then we just connect, extend, draw some arrows on the end. Notice we're not finding the slope, so you don't have another point. I mean, you could find the slope, but you're just connecting those 2 dots and extending your line. If there are signs, of course you have to use the signs. So when I do the x-intercept, then I'm using this. So I'm doing 20 divided by -4. And again, that might just be something that goes on in your head. 1, 2, 3, 4, 5. It is the x-intercept. I just wrote x, right? So if I solve that, I have x is equal to -4, or -5, sorry. That's why it's on the x line. Then I'm going to go do the y-intercept. So y is going to equal 20 divided by 5, which would be 4. That's my y-intercept, so it's on the y-axis. 1, 2, 3, 4. And then I can just line those two up with my ruler, connect, extend, draw some arrows on the end. So take the constant on the right, divide it by the number with the x. So 45 divided by 9, the x would be 5. And I like to just go ahead and put that on my graph before I even find the y. Probably because I don't usually write it down. 1, 2, 3, 4, 5. And then for the y, I have 45 divided by negative 15. So the y would be negative 3. So on the y-axis, 1, 2, 3. And then I can line those up and extend. So guys, notice that if I were to move it around to put it in slope-intercept form, I would move the x over, I would divide it all, each term by negative 15, and I would get y is equal to, that would be positive, I would have to reduce 3/5 x minus 3. So then I would start at negative 3, go up 3, and over 5. And in this case, I get the exact same 2 points. Sometimes you don't get the same 2 points, but it extends and goes through the same 2 points. So if you can get the hang of that, when it does divide nicely, it can be quite the time saver. Because we got lots of chances to make mistakes, like not reducing correctly or leaving out a negative or whatever. But if you did move it into slope-intercept form, you should get the same line. For number 10, our x-intercept would be 3.5 or 7 over 2, and our y, negative 7. I don't really like to graph with decimals. 3.5, I mean, halfway between is about the worst decimal that I'm going to try to estimate. So, but since this is, I'm supposed to be doing it with the intercepts, that's why, so I just estimate it between 3 and 4. And then 1, 2, 3, 4, 5, 6, oh, right at the bottom of what I can see on my screen. Oh, hello. Keep going, keep going, keep going. So homework 7. Also, you only have to do evens. So evens on homework 7. And then I'm not sure how everyone is coming along with their IXL lessons, but I also have some IXL lessons that I'll end up adding in there. Okay. So, but we'll have a little bit lighter day as far as instruction and more work time tomorrow. So any of that, but please try to get your paper assignments at least done, and the IXL lessons that are already assigned. I think it was T6 through 8 were the last ones I assigned. Should also have found, I gave you your paper homework back and an assignment summary, so that would also remind you of any IXL lessons that I had assigned as of last week. Yes.
Okay. In the A, if I